Now, this question is one of those scenarios where I would say that using Desmos is superior to any other method we could implement. So let's go ahead and look in the upper right corner, which is where Desmos is located for both our software as well as the real digital SAT. And we'll go ahead and zoom out here a bit. Now, something that's good to know, when you go to the tools, you do have the option of having this current font, or we could go here where it's a little bit more bold. I actually do like this right option. Now, let's look at the two scenarios of what you could do here. The first one, I'm not a huge fan of, but I'll show it to you anyway. So you could just type this in as is. So let me go ahead and zoom out a little bit here. I'm using my touch screen, but you could just press Control minus or Control plus to zoom in, and Control zero is back to just the normal viewing window. So let's say I go ahead and try to type these in. You could use the keyboard that's down here in order to do the square root, which is down here. And then we'll do 3. Remember, you're going to use x as your variable, squared plus 24. And we'll go over here, and then we'll just type in the right side, so 2x plus 2. So in that case, notice what it does. If instead I went to the original settings and had it here, it's not quite as clear, to be honest. And even this is a little bit smaller of a font. So I do like this option. So when we go there, and maybe I could zoom in a little bit, you can see very clearly that 2 is the x-intercept. And that's really what you're finding here. When you're trying to find the solution, solutions are really x-intercepts. And we could zoom out a bit, either using my touchscreen here or just pressing this zoom out button. And you can clearly see that's the only point of intersection. So that's one way you could do it. I actually prefer instead just typing in that left side as its own function, going ahead to the second one and typing in the second side as another function, and finding where they intersect. To me, that's a little bit more convincing to be able to see that, oh, they only intersect at that one point. And more specifically, if we click on it, we'll see the ordered pair, and we just want the x coordinate. That's always your goal, is to find the x value for where they intersect. So notice it's at x equals 2. And so when they say, what is the sum of all the solutions? Well, there's literally only one solution. So if you add 2 to nothing, you get 2. So we know the correct answer is going to be C. Now, in case you're wondering, well, how would I have done it algebraically? I'll show it to you just so that you can see the value of Desmos and how it is superior to doing it algebraically. But I think it's good for you to know the algebra behind it and just how much time you're really saving by using Desmos. So let's go ahead and give it a shot here. So what you would do is you'd go ahead and square both sides so that you can undo the square root. On the left side, we can see the square and the square root are just going to cancel, and you'll be left with 3m squared plus 24. And then on the right side, what we're going to have to do is go ahead and rewrite this as 2m plus 2 times itself, because that's really what squared means. And then when we distribute, we get 4m squared. And then if we do outer, we get 4m, inner, we get 4m, so we really get 8m. And then for last, we get plus 4. Now remember that in algebra, you always have basically two scenarios. If you have one type of m, like let's say just m to the first or m to the second, you would instead, let's use an example. If you had one type of x, you'd get x's on one side, numbers to the other. If, however, you had more than one type of x, remember that's the scenario where you want to get everything equal to 0 so that you can factor and solve. So you always want to ask yourself, which of those two scenarios do you have? Well, in this case, we have more than one type of m because we have to the second power. We also have to the first power. So let's go ahead and get everything equal to 0. More specifically, I'm going to move everything to the right side to keep the leading coefficient positive. So I'll move the 3m squared by subtracting it. Same thing with the 24. And we end up getting m squared plus 8m minus 20 equal to 0. And then I'm confident you would know how to factor it manually by factoring and saying, okay, what two numbers multiply to 20 and have a difference of 8? We know that's going to be 2 and 10. You need a positive times a negative, with the bigger one being positive. So that way you get positive 10, negative 2, which gives you positive 8. And then you set each of these equal to 0. So you have m minus 2 equal to 0, m plus 10 equal to 0. Obviously, Desmos was superior overall, but that doesn't give us the final answer. Because a common mistake people would make is they would say, okay, I'm going to add 2 and negative 10 because those are my two solutions, and I'm going to get negative 8. So I'm sure B is the most often incorrect chosen option. But what you have to do then is go back and plug in, let's say for example, -10. 2 times -10 is -20. -20 plus 2 is -18. You can never take the square root of something and end up with -18. In fact, if you plug it in, you should end up getting +18 on that side. That's typically what happens, is you'll get 18 equals -18, which obviously is not true. And so we consider this an extraneous solution. But if you plug in 2, you will get both sides equal. In fact, if you plug in 2 here, notice you'll get 6 on the right side. If you plug in 2 here, 2 squared is 4, 4 times 3 is 12, plus 24 is 36, the square root of which is 6 as well. So this ends up being your only correct answer. So when you add up all these solutions, you still get C.